So in this video, I will walk you through how to value a call option using a one-step binomial tree. And I will also touch upon the put-call parity and highlight the aspects that I believe to be testable. So let's get started. So basically in this example, right now we have a call option that is expiring in 3 months. And we are calculating the value of a call option using a one-step binomial tree. And of course, we are given that the value of the underlying is 50 as of right now. And we are also given the upward and downward magnitude, based on which we can go ahead to populate the binomial tree. Now, for the sake of simplicity, we are given the upward and downward magnitudes, but in case we are not given, these can be calculated applying this formula over here, which, as you can see, can be easily calculated if we know the volatility of the underlying and the length of the time period in the binomial tree. In terms of other information, we are given that the strike price of this option is 52, and that the risk-free rate is 3%. And basically, this set of information is enough for us to calculate the value of this call option because we do not need the real-world probabilities of each outcome. And you will understand everything in a bit. And basically, when it comes to valuing options, you need to understand that unlike the value of the underlying, which is calculated by moving forward, the value of the option is calculated by moving backwards, which is also called as backward induction. So basically, we start computing the value of the option after 3 months, and this is done by using the simple payoff formula that you can see on the screen. So basically, the value of the option would be 8 if there is an upward move in the underlying, and 0 if there is a downward move in the underlying. And I'm sure that this part feels familiar and straightforward. So basically, in order to calculate the value of this option at time 0, we need to have something called the risk-neutral probability for both an upward and a downward move. And needless to say, the risk-neutral probability of a downward move is basically expressed in terms of the risk-neutral probability of an upward move, or of course the other way around. So speaking straight from the conclusion, the value of this option at time 0 is this value over here, and let me walk you through the calculation step by step. So this is the expression that leads to this value, and what I want you to observe in this expression is that this expression can be divided into 2 major parts. The first part is the probability weighted expected value, and the second component is the present value factor. And basically, what I want you to notice over here is that we have all the necessary inputs in front of us, because this component over here is the risk-free rate, which we are given to be 3%. This component over here is the length of the time period, which is given to be 3 months. This value over here is the value of the call option, assuming an upward move in the underlying, which is calculated to be 8. And this value over here is the value of the call, assuming a downward move in the underlying, which is calculated to be 0. So basically, all of these are given variables except for this one over here, which is basically the risk-neutral probability that is calculated using this expression over here. Now, the logic for this particular formula will be covered in my next lesson, so for the time being, let's just focus on the big picture. And basically, what I want you to understand at this stage is that we have all the necessary inputs to calculate this risk-neutral probability. And this is because, as you can observe, this component over here is the risk-free rate, which we are given to be 3%. This component over here is again the length of the time period, which is 3 months. These components over here reflect the downward magnitude of the underlying price, which is given to be 0.8. And lastly, this component over here is the upward magnitude of the underlying price, which is also given to be 1.2. So basically, if we plug in the numbers in this formula, we would get the risk-neutral probability of an upward move to be 51.88%. So basically, now that we have the risk-neutral probabilities calculated using the inputs that we were given, we can go ahead and plug in the numbers in our original formula. And if we do this calculation, we would get to this value over here. And this value over here is nothing more but the value of the call option as of right now, which is basically the end result of this calculation. Now, before I wrap up this lesson, there is one more aspect that the curriculum is highlighting, so let me just illustrate that within this context. So basically, we just calculated the value of the call to be 4.120. And let me ask you, what is the value of an equivalent put? And this is where the put call parity comes into play, which is defined through this expression over here. And basically, what I want you to see in this relation is that if we know the value of the call along with some basic inputs about that call, we can basically compute the value of an equivalent put. Let me show you. So basically, we know the value of the call to be this value over here. We know the strike price of the call, the present value of which would be this much. And we also know the underlying price. So essentially, if we solve this equation, we would get this value for the put. Now, there is one more thing that I want you to understand about put-call parity, and that is that this relation holds true so long as both of the options share the same characteristics. And what this means is that both of these options have the same strike price, the same expiry, and the same underlying.